Well, greetings, Mr. Colazar's class. The last section is on phase diagrams, section 12, 5 in our notes, looking at this idea of solids, liquids, gases. So phase diagrams, graph that represents pressure and temperature and which of the phases that we exist in those different conditions. There are three regions, solid, liquid, and gas, but we call it vapor as a gas. And so our first part is where our liquids are at. Where's our vapor? Remember, vapor is a term for gas. There we go. And then our last part, our solid. So at what pressure and what temperature you're at determines your state of matter. So as we're working, if you're in the section up above here, you'd be a liquid. So depending on what temperature you're at and what pressure you're at, again, 100 degrees Celsius, boiling for water, 0 degrees Celsius, freezing for water, at 1 atmosphere of pressure, those would be our normal boiling and our normal freezing points. So if you're above 100 degrees Celsius, you'd be a gas at that one temperature. If you're below 0 degrees, you're a solid. So where at on this graph are you at? Our last key part here is the boundaries. Boundaries mean that you're on a line. So if you're on the line between the two, that's the part where a phase change is occurring. So you're going between a liquid and a gas, you'd be at evaporation or boiling point or condensation. If you are along our line here, we're between a liquid and a solid, so you'll be between melting and freezing, freezing and melting. So when you're on the boundary line, you're in between the two. And our last one, between a solid and a gas, is our deposition sublimation. So that's when you're changing states of matters if you're on the line. From there, we've got a couple of key parts. Normal boiling and melting points, temperature at which a substance boils at 1 atmosphere is our standard condition. So at 1 atmosphere, we'd have our normal boiling and our normal freezing points. So whatever they might be, an example here, 0 and 0, that's for 0 and 100, that's for water, normal boiling and melting points. Triple point. Triple point is that temperature and pressure which all three states of matter coexist. So our triple point is where we can actually have a solid, a liquid, and a gas all existing together at that same state of matter. So we can be between those three there. And then our critical point, way up towards the top here, our critical point, at this temperature and higher, no amount of pressure will get a vapor back to a liquid. So once we get up to this temperature, whatever it might be, it doesn't matter how much pressure we apply, we can never get it to become a gas or become a liquid. It'll always be a gas. So as we're going, no amount of pressure will change that vapor back into a liquid. At that point and further on, we're only going to be a gas, no matter how much we try to force it in. So a couple ideas with phase diagrams. When we think about ice skating, when you're ice skating, you're applying pressure to that ice. As you apply more pressure, we actually move into the liquid stage. And so when you actually are ice skating, increased pressure causes solid to change to liquid, so you're actually skating on a fine amount of liquid as you're going. Boiling under 100 degrees Celsius, our normal boiling point, 1 atmosphere, 100 degrees Celsius. If you decrease that, you're going to boil at a lower temperature. So as you decrease that pressure, you boil at a lower temperature, so higher up in elevation. We talk about cooking in the mountains, can be a problem there as we're going. And then another interesting one, like a propane tank or a Bic lighter, would be examples of as you increase pressure, as your pressure goes up, you can actually force a gas to become a liquid as that pressure goes up. So examples of that, increase in pressure can change from a gas to a liquid. So your propane tank at home holds a lot more material as a liquid than a gas. So we can have more material put in there or stored in there. Another example, our Bic lighter, you can actually see that volume of how much gas is actually, excuse me, how much liquid is in there. The liquid, you can store a lot more material so that for storage purposes, for it to be used, we can see that there. So interpreting phase diagram where our solids, liquids, gases are at, and along the line that state of matter changing places. Kind of an interesting one that we use in here, dry ice. An example there, dry ice is going to be a solid, but at our pressure temperature, it goes right from a solid into a gas and it skips that liquid state. So as we're reading or interpreting our graphs, sublimation is that idea of going right from the solid to a gas, not going through that liquid state of matter would be a good example there. So as we're working, that's just a way for us to go through and actually determine which state of matter we're in by pressure and temperature. Remember, on the line is that phase change occurring between those ones. Hey, safe travels to everybody.